So, a pleasant morning to all dear students, and today we are going to see an important topic. So, we have started the lesson ray optics. In that we have gone through what is reflection and what are all the cases that follows reflection, and later on we have started refraction. So, just for a small recap here, we know what is refraction. So, here when a ray passes through, okay, whatever the source may be, we can say from the sun I get a light ray. When it passes and hits the surface, okay, when it hits the surface, it refracts, right? It refracts, and we have a normal which we draw here. So, this ray is called as incident ray, this ray is called as refracted ray, which we name this as normal, which is perpendicular. This surface is the striking surface, which is called as point of incidence. Okay, the surface is called as point of incidence, and the angle which is being formed, which we call it as angle of incidence and angle of refraction. How we study a human anatomy, same here. Here we call this an anatomy of a refraction structure. Right. So, here we are clear about what is refraction. And next we have seen refraction at a single spherical surface. In case we know in mirror we read reflection. Okay, when we read with the help of lens, that is refraction. When it comes to mirror, we call that as reflection. So, with the help of this lens, right, we have two lenses. We know one is convex lens and one more is concave lens. So, when it has a cave-like structure like this, we call it as concave, and we have a bulged outside surface, it is called as convex. So, with the help of this one side, okay, what single surface spherical structure, we have derived a final formula. That formula, what we used here is N by V, okay, N by V minus N by U, which is equal to 1 by R, N2 by R1 or R, N2 minus N1 divided by R. Okay, this is the final formula which we have derived here. Okay, which is the final formula which we have derived, N2 minus N1 divided by R. Right? So, with the help of this formula, so make this as a basic. With the help of this formula, we are going to see a small derivation which is called as lens maker's formula. So, our today's topic is lens maker's formula. So, most of us in this present scenario, when we see, most of us wear specs, right? When the doctor checks us and he will say, this power plus 2 or plus 1.5 or plus 0. They will place different lenses in our eyes. So, they will have some different spectacles, okay, which they have, and inside that they will keep different lenses and ask us to read the board which is opposite to us. They will use some prism to check our refractive index of the eyes, same as they will use some different lenses to know what power for us which has increased, or what is the level of our power. We know the vision of accommodation, which is 25 centimeters. So, the maximum distance, so the minimum distance, only when we keep the book at 25 centimeters from our eyesight, we can read that clearly. When it is very close or when it is far away, there may be a small differences in the letters we read, right? So, here when we, after getting all this checkup is over, after getting that prescription from the doctor, straight away we don't go to the glass shop, we select whatever the frame we love, and finally what we do, we give that chip to them and they make, and finally with the help of that specs we'll be able to see the objects very clearly, the letters very clearly. So, based on this lens maker's formula, they apply this and they set up all those glass which we use, the lenses. Okay, they will have separate, in 10th you would have read about this presbyopia, myopia, metropia, hypermetropia, depending upon short-sightedness, long-sightedness, and both in case after the age of 40, most of the people will use two lenses, one for reading and one for vision, all those things, right? So same here, with the help of this, we are going to prove this 1 by V minus 1 by U, which is equal to 1 by F. So this is called as lens maker's formula. In 10th you would have read this for mirror. When it comes as plus, we call that as mirror formula, and when it is minus, we call that as a lens maker's formula here. So first from the lens we have chosen a lens. Okay, we know this is a convex lens which is bulged outside. To make it very clear to know the difference, cave-like structure will be concave, right? So have that in mind. So the opposite will be convex. So I have taken a lens, okay, which is convex lens. And here I have placed an object, okay. So this is the object O, and from this I am passing a ray. So this is a source of light. When I am passing the ray, right, it hits the surface. So this is the point of incidence. And when it hits, automatically we know if there is no surface at all. If there is no surface at all, this ray will go like this. But here what happens? I have a surface so that it refracts. So this medium, I name it as N1. We know this is a rarer medium. And here inside this, we call this as a denser medium. So inside a small refraction happens, and when the ray emerges out, again from denser, it comes to a rarer medium. Okay, so what I am saying, this I am naming it as N2. Where we will give this like N1 and N2 and all. Generally N we say it as refractive index. Okay, N we say it as refractive index, or we can also use a symbol called mu. Okay, we know that we don't have a unit for this. Mu is equal to C by V, depending upon the speed of light in wake up and the medium which we use, right? So here this is denser and these two mediums are rarer. So I can name this as N1 itself because this is also rarer and this is also rarer here. Clear? So we have these two mediums and this is denser, which is N2. So now just listen clearly. When it hits here, it refracts, right? It refracts, and when it passes out, you just imagine we don't have the second surface at all. Okay, like the previous topic, when we take a single surface, this ray will go in this direction, right? But here what happens? I have a surface here, so again refraction will happen. So this is the extra refracted ray, where this is the original ray. Okay, that is original image what I get from the object, and this is the refracted image. Okay, this is the refracted image, whereas this is the original image. And we know object distance we always denote with U, and the image distance we always denote with V. As this is for the refracted image, it is V, and for the original image, it is V dash. Right? Hope you are all clear up to this. So from this diagram, we are going to derive the equation. It's a very easy equation, right? So let us start here. So the first thing we are going to start here is, I am going to consider this surface. Make it as number 1 and make it as number 2. Right, 1 and 2. So here it is also like N2, N1. Okay, so always we have to take refractive index of second medium to the first medium. Okay, you just imagine, you just note on this. This is an important point. Refractive index of second medium to the first medium. So that is very important here. Second medium to the first medium. So when I consider this is the second medium, so N2, okay, for the second medium N2, which is divided by V. I have taken this image, so I am taking V because of this image is formed, because of this object, this image, because of this object, this image I get. So for N2 divided by V, so automatically we know it is N1 divided by U minus N1 divided by U, which is equal to same here N2 minus N1 divided by R1. Okay, the same thing we are following. Make it as first equation here. And second case, now you just ignore this. We don't have a source from here. Instead, make this as a source. Only from here, from the straight away on the lens, we are keeping the source, the light. So what will happen? This will become the first medium and this will become the second medium. Good, very good. So here N2, same as here it is N1 because this is a second medium. So N1, right? N1 divided by V minus N2 divided by V. Okay, sorry. And here we have N2 divided by V dash. And here is also V dash because, so for this is the original image. We are considering the original image. So N2 divided by V dash, which is equal to N2 N1. Here it depends upon second to first medium. So N1 minus N2 divided by R2. First medium to the second medium. Right. So what? Here now we are going to equate this both. Okay. Equate 1 and to make this as the second equation. So what is common here? This is N2 by V dash and N2 by V dash. So we can cancel. This is in plus and this is in minus. So what remaining we have here? N1 by U minus N1 by V minus N1 by U, which is equal to, see here R1 R2, N2 minus N1. Only if it is N2 minus N1, I can take this as common. So what I am doing here is I am taking minus outside. Only in this I am saying, okay, I am taking minus outside. So what will happen? This will become minus N1 and this will become plus N2. Just to take this minus inside, minus into minus plus. Again you will get this and this minus into plus will become minus. So you will have minus N2. Hope you understood. So when I take this minus outside, I can write this as N2 minus N1 divided by 1 by R1 minus 1 by R2. Okay. So next in this what is common? N1 is common, right? So here itself I can take that from this equation. N1 is common, so that I can make it as 1 by V minus 1 by U, which is equal to N2 minus N1. So again next here, to take this N1 outside, I have N1 as common, so divide by N1. So when I divide by N1 by N1, which is equal to 1 by V minus 1 by U, which is equal to N2 minus N1 divided by N1, 1 minus R1 divided by 1 minus R2. Clear? So in the next step what? Here this can be get cancelled and this will get cancelled, and what all remaining I will have? 1 by V minus 1 by U, which is equal to N2 by N1, okay, minus 1 by R1 minus 1 by R2, right? So N1 minus N1 is 1, right? And next, so we have a substitution here. In the place of N2, we can always write N1 and we consider this N1 as always a air medium. So the value of air medium is 1, right? So substitute now. 1 by V minus 1 by U, right? Which is equal to, in the place of N2, yes, N, and the place of N1, 1. So it is 1, right? So we can neglect that, right? It is 1. So N minus 1 by R1 minus 1 by R2. Okay. So now you make this as third equation. Clear? And next step, now we are going to give a value. We have this ray diagrams. You would have read about the ray diagrams giving some conditions. If I place the object at infinity, if I'll get the image somewhere. So same as here, we are going to substitute, that is U is equal to infinity. So object is infinity, whereas V, okay, in the place of V, which is equal to F. So we can substitute here. So in the place of V, we have 1 by F minus 1 by infinity, which is equal to N minus 1 by R1 minus 1 by R2. Clear? So what can be done here? This 1 by infinity, which is equal to 0. Anything divided by infinity is equal to 0. So now I have a fourth equation. Now can we equate equation 3 and 4? So now equate 3 and 4. So when you equate this is common, this is common, and what we have remaining? 1 by f, which is equal to 1 by v minus 1 by u. So what we are supposed to prove here? 1 by v minus 1 by u, which is equal to 1 by f. Clear? So just go through, okay, go through this, use this diagram, draw the diagram clearly, have all those points. So this is the easiest question and where we can gain marks also easily. So in this sum, they may ask you to find f, or sometimes they will give this refractive index values. Straight away they will give this equation and they will give you the refractive index values. They may ask you to find v or u or f. Okay, so even you will get problems based on this question. Clear? So hope you don't have any doubt. If you have doubt, we can clarify it. Thank you.